Welcome to the third episode of our Basic Prompt Engineering podcast series. In the last episode, we covered the fundamentals, and in this episode, we're going to dive much deeper and break down advanced prompting techniques. If you're ready, let's start exploring the methods that will take your communication with AI to the next level. When you first start using these AI models, it really does feel a bit like magic, doesn't it? You just type something in, and boom, out comes text or an image. It's pretty amazing. But then, pretty quickly you start to realize that the way you ask, the quality of your input dramatically changes the output. It's not just about being polite, right? It's more about understanding maybe how these models actually think or process information and giving them the precise guidance they need.
That's exactly it. It's less like chatting with a person who can kind of infer your meaning and fill in the gaps, and much more like programming a really flexible computer, but you're using natural language as your code. The specific methods we use to structure our inputs, our prompts, they have a direct measurable impact on how effective, how relevant the AI's response is going to be. It's really about moving beyond just simple requests like asking for the weather to crafting inputs that unlock the AI's, its full potential.
And this is so crucial, whether you're just playing around, maybe prepping for a meeting or, working on really technical projects, getting reliable results or getting output in the right format or having logically reasoned answers that could be a total game changer. We've gathered some really fascinating sources that lay out several powerful techniques, and we're excited to unpack them for you in this deep dive. So, okay, where do we even start? If someone's just typed a question into an AI like, what's the capital of France? And hit enter. They've already used the most basic form of prompting, right?
Exactly. That's the foundation. That simplest interaction, just giving the task instructions straight up. That's generally called zero-shot prompting definition. So zero-shot prompting is basically when you ask the model to do something based only on your instruction. You don't give it any prior examples within the prompt itself. It has to rely completely on its existing training data, everything it learned beforehand, to figure out what you want and how to do it.
Okay, so just the task itself. Summarize this article. Translate the sentence, no extra help.
Yeah.
When is this the right way to go? What are the primary uses for this zero-shot approach?
Use case. Well, it's great for straightforward requests. When the task is relatively simple and you're not too fussy about the exact output format, quick questions, basic information retrieval, like your capital of France example, or maybe asking for a simple definition. If the task is something the model has likely seen countless times in its training, zero-shot can often work just fine. It's the quickest way to get an answer.
Got it. Minimum effort, potentially okay results for simple stuff. But I bet there are limitations. I mean, where does it start to fall down?
Oh, absolutely. Huge limitations. While these models have, frankly, remarkable zero-shot capabilities on a wide range of tasks, they often stumble when things get more complex, or when you need a really precise output format, or maybe some kind of multi-step reasoning.
Right, like it might give an answer, but not necessarily the right answer, not in the way you needed it.
Exactly. It can misunderstand the nuances or just fail to follow the logic required. Example, demonstrating limitation. Let's take a concrete example from one of the sources. It's a reasoning problem. The statement is, the odd numbers in this group add up to an even number, 15, 32, 5, 13, 82, 7, 1.
Okay, so a list of numbers, and the task is just to say if that statement is true or false.
Yeah.
Using zero shot.
Precisely. Just give it that sentence and ask true or false. No hints, no examples of how to figure it out. What happens? Well, without any further guidance, the model might try the calculation, but it could easily get it wrong or just completely misinterpret the core of the question. One source showed a typical zero-shot attempt resulting in something like, yes, the odd numbers in this group add up to 107, which is an even number.
Whoa. Okay, that's wrong twice. First, the odd numbers there, 15, 5, 13, 7, 1, they add up to 41, not 107. And second, 107 is definitely not an even number.
Exactly right. It shows the model making errors in both the calculation and the final logical check. And importantly, it just gives you the wrong answer confidently. It doesn't show its work, so you don't see why it failed.
That makes perfect sense. It just spits out an answer, and if the internal logic was flawed, you just get confidently wrong output.
So how do we improve on this? Especially for tasks that need more guidance or a specific structure. How do we give it that missing context? Well, that naturally leads us to the idea of providing the model with some information to learn from, right there in the prompt itself. This brings us to our next technique, few-shot prompting definition. All right, so few-shot prompting is where you include a small number of examples. These are the shots directly within your prompt. These examples demonstrate the pattern you want. They show an input and the corresponding desired output. This guides the model towards the correct format or the right style or how to execute the task properly.
Ah, okay. So instead of just asking, you show it first a
Yeah.
few times. Like, here's an input, here's the kind of output I want, here's another one, now do it for this new input.
Exactly. You're providing demonstrations. These examples work as in-context learning. The model looks at the pattern in your examples and tries to apply that same pattern to your actual request. It conditions the model just for that one interaction to produce a response that matches the structure and style you've shown. And interestingly, some research suggests that even using examples with random labels can help as long as the format is consistent. The structure itself is a powerful signal.
So the format is key.
Hugely important. Clearly labeling your examples, maybe with INPUT and OUTPT markers, helps the model recognize the pattern you're demonstrating. Use case. This technique is really powerful for tasks where you need the output to follow a very specific structure or format. Think about structured information extraction, like pulling details from a block of text, or classification tasks like sentiment analysis, positive, negative, neutral, or even generating content in a particular style, like maybe writing product descriptions that all follow the same template. It helps improve accuracy quite a bit compared to zero shot, especially when you need more than just a basic fact.
Okay, that sounds very useful, especially for technical tasks. Can we walk through an example, maybe that information extraction idea?
Example 1, structured extraction. Yeah, absolutely. Let's say you need to extract key details from job postings to feed into a database or an automation script. This is a super common technical use case. Bad zero-shot approach. Implied. If you just paste in a job posting and say, extract the details, what do you get? Probably a messy paragraph summarizing it, right? Not very useful for a script.
Right, you'd have to parse that paragraph yourself. Painful.
Exactly. Good a few shot approach. Instead, you provide an example first. You clearly structure it. In PUT. Software engineer Python specialist needed at Tech Corp, 5+ years experience required. Salary range $90,000 to $120,000. Remote work available. Apply by June 30, 2024. OUTPUT, position, software engineer specialization, Python company, Tech Corp experience required, 5+ years salary range, $90,000 to $120,000 work type. Remote application deadline, June 30th, 2024. See how structured that output is.
Now, after showing it this example,
You give it a new job posting as the INPUT and just ask for the RTPUT. Precisely. And the model, having seen the example, now knows to look for those specific pieces of information and present them in that exact clean line-by-line format with those labels. It's learned the extraction pattern and the output structure on the fly. Using those distinct markers like INPUT and OUTPUT is really crucial here. It helps the model see the transformation.
that's really clear. You're essentially programming the extraction logic with an example. Do you use this for creative stuff too? Getting a specific writing style.
Example 2, content creation style. Yes, definitely. Another source gave examples for generating travel itineraries. Imagine you want itineraries written in a certain very descriptive style. You could provide a few examples. Maybe one for Tokyo, focusing on cultural sites, another for Costa Rica, highlighting eco-adventures, a third for Rome, centered on food. Each example would follow your desired format, maybe day-by-day breakdowns with vivid descriptions.
And then you ask it for a new itinerary, say for Paris.
Right. And because it's seen the pattern, the style, the level of detail in your examples, it's much more likely to generate the Paris itinerary following that same established pattern and tone rather than just giving a generic list of landmarks.
So it learns the structure and the style from just a few examples.
Mm.
That is powerful. It feels like a big step up from zero shot. What are the downsides, though? Limitations.
Limitations. Well, the biggest one is the context window size. Every model has a limit on how much text it can process in a single prompt. Few-shot prompts require you to include all the input-output examples plus your actual query. If your examples are long or you need many of them to cover different cases, you can hit that limit pretty quickly.
Ah, right. You just run out of space in the prompt.
Exactly. Another potential issue is sometimes the model might latch onto superficial patterns in your examples without really understanding the underlying task. It might copy the format perfectly, but still make logical errors on the actual content if the task is complex.
Right. Like we saw with that initial few-shot attempt mentioned in the source for the odd numbers problem. It might have gotten the true-false format right after seeing examples, but it still got the underlying math wrong. It seems like for tasks that require genuine multi-step thinking or reasoning, just showing examples of the final output isn't quite enough. You need to guide the process itself somehow.
You've hit the nail on the head. For complex reasoning, guiding the intermediate steps is key. And that brings us to chain of thought, or CoT, prompting. Definition. So chain of thought prompting is a technique where you specifically instruct the model to generate a sequence of intermediate reasoning steps before it gives the final answer. It's like asking the AI to show its work. Just like in school, you want to see the logical path it took.
Ah, the show your work method. I like that. It forces the model to explain how it arrived at the response. I remember one source used an analogy like explaining a complex idea step by step, almost like you're talking to an 8-year-old, making each step really clear.
That's a perfect analogy. Models, especially when faced with tasks requiring multiple logical steps, often benefit greatly from breaking the problem down. They need that guidance. By embedding these logical steps, this chain of thought, either directly in few-shot examples or just by asking the model to generate them itself, sometimes simply adding, let's think step by step, can trigger this. You unlock much more sophisticated reasoning.
So you're prompting for the thought process, not just the end result.
Precisely. Use case. CoT is particularly powerful for tasks that need multi-step reasoning. We're talking mathematical problems, complex word problems, common sense reasoning where logic isn't explicit, symbolic manipulation like maybe solving logic puzzles, and even complex decision-making or planning tasks. Sources also specifically mention how effective it is for programming tasks that naturally follow a logical sequence, and for generating things like instructions or recipes, procedural text, where the order of steps is critical.
Okay, so anything involving steps or logic, why is it so much better for these types of tasks? What makes it so powerful?
Why powerful? It dramatically improves reasoning capabilities because it allows the model to tackle a complex problem by breaking it into smaller, more manageable chunks. Each intermediate step is simpler for the model to process correctly than trying to leap directly to the final complex answer, and the results are often striking. Studies mentioned in our sources show really notable performance increases. We're talking things like a 12% accuracy boost on certain question types, like Boolean questions, and even a 15% jump on challenging reasoning benchmarks, like the AI2 ARC questions, just by using CoT compared to standard prompting.
Wow, 15% is a huge improvement on difficult problems.
It really is. And beyond just accuracy, it provides crucial explainability. You can actually see the model's reasoning. If the final answer is wrong, you can often pinpoint exactly where the logic went astray in the steps. That's invaluable for debugging and understanding the model's limitations.
That explainability factor is huge. Okay, let's revisit that tricky odd numbers problem one more time. 0 shot failed badly. How would CoT handle it?
Example, arithmetic revisited. Right, the problem. The odd numbers in this group add up to an even number, 15, 32, 5, 13, 82, 7, 1. Good CoT approach. You'd either provide a few-shot example showing step-by-step reasoning on a similar problem, or you could just add the magic phrase, let's think step-by-step, to your 0-shot prompt. The model's response would then ideally include the breakdown. It might output something like, okay, let's break this down. First, identify the odd numbers in the list, 15, 5, 13, 7, 1 point. 2. Next, sum these odd numbers. 15 plus 5 plus 13 plus 7 plus 1 equals 41. 3. Now determine if the sum 41 is an even number. An even number is divisible by 2.4. 41 divided by 2 is 20.5, which isn't a whole number, so 41 is odd. 5. The original statement claimed the sum is even. Our calculation shows the sum is 41, which is odd. Therefore, the statement is false.
That's crystal clear. It follows the logic perfectly and arrives at the correct answer because it followed the steps. It didn't just jump to a conclusion. Huge difference. So CoT tackles the how of reasoning. What about controlling the style or the perspective of the output, making it sound like it's coming from a specific type of person or expert?
Ah, yes. That's another very common and often highly effective technique. Assigning a role, sometimes called the persona pattern definition. Role prompting, or persona prompting, is where you explicitly tell the AI model to adopt a specific identity or persona for its response. You literally start your prompt with something like, you are a specific role, or act as a specific persona.
Like, you are a skeptical journalist investigating this claim,
Yeah.
or you are an enthusiastic tour guide describing this landmark. You're basically casting the AI in a role.
Exactly that. Use case. You use this to steer the style, the tone, the vocabulary, and even the kind of information the model focuses on. It's incredibly useful when you need a response tailored to a specific audience or context. Need a formal business letter, act as a senior executive. Need a simple explanation for a child, act as a friendly teacher. It helps guide the output towards a very specific tone and structure, hopefully matching your exact needs much better than a generic response would.
Okay, that sounds intuitive. Can we see an example?
Example, food review. Sure. One of the sources used a food review example, which illustrates it nicely. Bad simple prompt. If you just say, write a review of some pizza place. The AI might give you something very bland and generic, right? Like, I went to pizza place. The pizza was okay. Service was fine. Functional, but boring.
Yeah, pretty uninspired.
Good role prompt. Now try this. You are a passionate, world-renowned food critic. Write a review of the same pizza place. Suddenly, the language changes. The output becomes much more descriptive, uses more sophisticated vocabulary, focuses on sensory details, maybe discusses technique. You'd get something like, stepping into pizza place felt like discovering a hidden gem. The margarita pizza arrived, a masterpiece of simplicity. The crust, oh, the crust, a sublime interplay of char and chew whispering tales of a perfectly managed wood-fired oven. The San Marzano tomatoes sang with authentic sweetness. You get the idea.
Yes, definitely more character. And I remember the source mentioned you could even specify which publication the critic writes for, like Michelin Guide, to get an even more specific, perhaps more formal and critical tone.
Exactly. The more specific the role, the more tailored the output. Example, email tone. Another source showed this with email tones. Asking the AI to write about a delivery delay as a marketing expert produced an email focusing on building anticipation and maintaining brand loyalty.
Right, sort of spinning the delay positively.
Kind of, whereas asking it to write the same email as a customer service representative resulted in a message focused on apology, empathy, and offering concrete solutions or compensation. Same core information, completely different framing based on the assigned role.
That's a very clear demonstration. Does this work equally well on all models?
Nuance. That's a good question. The sources suggest that while role prompting had a massive impact on older models, say GPT-3, the effect might be slightly less dramatic on newer, more advanced models like GPT-4, which are already better at inferring context and appropriate tone. However, it's still a very valuable and often necessary tool, especially if you need a highly specific or unusual persona, or if you want to guarantee consistency across many outputs. Providing a detailed description of the role's characteristics often helps too. It's still a great way to control the flavor of the response.
Okay, so still definitely in the toolkit. Now, let's shift gears a bit. Thinking specifically about technical users, maybe in DevOps or automation, getting the output in a precise format is often the most critical thing. How do we ensure the AI delivers data exactly how a script or another system needs it?
Yes. This is absolutely fundamental for many practical applications, especially when AI outputs need to be machine readable. This technique is all about specifying the output format, definition. This involves being crystal clear in your prompt about the exact structure, syntax, or format you want the AI's response to follow. You're telling it how to present the information. This could mean explicitly requesting JSON output or Markdown, a numbered list, a comma-separated list, a specific table structure, maybe even code conforming to certain style guides.
So not just what info, but how it should be laid out. Why is this so critical, especially for those technical folks?
Use case and importance. For anyone in DevOps, data science, software development, or building any kind of automated pipeline that consumes AI output, this is non-negotiable. Imagine using an AI to generate, say, a JSON configuration file. If the AI decides to wrap that JSON in chatty sentences like, sure, here's the JSON config you asked for, or adds comments, or messes up the brackets, your downstream script will break instantly.
Right, the parser will just fail.
Exactly. Specifying the output format clearly, output only the JSON object, nothing else, is critical for ensuring the output is immediately usable. It saves huge amounts of time and reduces errors compared to trying to clean up poorly formatted output later. It also helps the AI understand your intent better by providing a clear target structure. It reduces ambiguity.
Make totally sense. Can we connect this back to the earlier examples, like the job posting extraction?
Example 1, structured data. Absolutely. With the few-shot example for job postings, we guided it towards a bulleted list format. To make it even more robust, you'd explicitly add to the prompt. Format the output as a markdown bulleted list using the exact labels shown in the example. Or, even better for machine processing, output the extracted job details strictly as a JSON object. Use the following keys: position, specialization, company, experience required, salary range, work type, application deadline. Ensure the output is valid to JSON and contains nothing else. That leaves very little room for error.
Very precise. I see how that's essential for automation. Are there other kinds of format specification?
Example 2, strict text structure. Yes. One source discussed prompts for generating cold sales emails where the visual structure was paramount. The prompts included strict rules like maximum 75 words, use short sentences, and even insert a paragraph break after every single line to create lots of white space for easy scanning on mobile. That's specifying format for human readability and impact, not just machine parsing.
That's interesting. Controlling layout like that. What about those special characters people sometimes use in prompts, like triple backticks or hash symbols? Is that related?
Example 3. Formatting cues. Yes, that's definitely part of it. Using formatting cues within your prompt helps the AI understand the structure of your instructions. Sources mention using things like hashtag tag, or to clearly separate different parts of your prompt, maybe instructions from context or context from examples. And crucially, using triple backticks to enclose the part of your prompt where you want the AI's actual output to go, or to specify that the output itself should be a code block, is a very common and effective convention. It tells the model, treat this part literally, which is vital for code, config files, or any structured text where you don't want conversational fluff or markdown interpretation messing it up.
Okay, so those backticks are like saying raw output goes here.
Pretty much. Example 4, beyond text. And this idea of format specification even applies beyond text. Think about image generation models like Stable Diffusion. The syntax used in those prompts, like using parentheses keyword to increase weight, or square brackets keyword to decrease it, or keyword 1.2 to set a specific emphasis level, those are all forms of format specification within the prompt language itself. Using the break keyword tells the model to process prompt segments separately to avoid concepts bleeding together. These are all instructions about how to interpret the prompt structure to influence the final output's characteristics.
Wow, okay. So format specification is really fundamental across different AI modalities, essential for reliable, usable results, especially in technical pipelines. We've covered quite a range now. Basic requests, learning from examples, showing reasoning, controlling style, and locking down the format. It feels like a solid toolkit. Is there another level, something more advanced, maybe combining reasoning with needing information the AI doesn't have internally?
Yes, there is. That brings us to a more complex and powerful technique known as REACT, which stands for Reason and Act definition. REACT is an advanced prompting framework where the model doesn't just think reason, it also performs task-specific actions based on that reasoning, and then observes the results of those actions to refine its next step. It's a loop. Reason, act, observe.
Whoa. So it's not just processing the information you give it or what's in its training data. It can actually decide it needs to do something, like perform a search, and then use the results of that action.
Precisely. Use case. REACT is designed for tasks where the AI needs to interact with external information sources or tools to find the answer. Think about questions requiring up-to-the-minute information, like today's stock prices, complex planning that involves checking external states, or tasks that necessitate using a specific tool, like a calculator or an API call. It allows the model to go beyond its static knowledge.
So it can actively seek out information it realizes it's missing. How does that work in practice, that reason, act, observe loop?
How it works. Typically, when using a REACT approach, the model's generation process explicitly follows these steps, often showing them in the output. 1. Thought. The model first articulates its reasoning. Okay, the user asked for X. To answer this, I first need to figure out Y. I don't have Y internally. This is like the chain of thought step. 2. Action. Based on the thought, it specifies an action to take, often formatted like a command. Examples might be action. Search latest news on topic Z, or action. Calculator 123456, or action. Look up customer 789 database. 3. Observation. The system then, in a real implementation, executes that action and feeds the result back to the model as an observation. Observation, search return articles A, B, C, or observation. Calculator result is 56088. The model takes this new observation, integrates it into its understanding, and starts the cycle again with a new thought, leading to another action and observation, continuing until it determines it has solved the problem and can generate a final answer.
That loop thought, action, observation sounds incredibly powerful. It makes the AI much more proactive. How does this compare to something like RAG retrieval augmented generation, which also involves retrieving information? They sound related.
That's a really important distinction, and the sources do touch on this. They are related but different. Both RAG and REACT can use private databases for content grounding, making the AI aware of your specific domain knowledge.
Right, so they can both look things up in your company's documents, for instance.
Yes, but the key difference is how and when. RAG primarily works by finding relevant documents from your database before the main generation starts and stuffing that relevant text into the initial prompt context. It's about augmenting the prompt with retrieved knowledge up front. React, on the other hand, is about the model reasoning during generation that it needs information, then formulating an action to get it, which could involve searching your database or searching the public web or calling an external API, and then incorporating the observation into its ongoing thought process.
I see. Ruby is mostly about preloading relevant context. React is about dynamic, reasoned actions during problem solving, potentially reaching out to external, even public resources.
Exactly. React allows the model to be more autonomous in finding what it needs step by step as it works through the problem, rather than just relying on what was retrieved initially. Example, financial data retrieval. Let's use that financial example again. You ask for a company's earnings for both 2010 and 2022. Let's say your private database, used by a RAG or potentially as a React tool, only has the 2022 data.
Okay, so standard methods, maybe even argy if it only finds the 2022 doc, might just give the 2022 number or make up the 2010 one.
Right, it might hallucinate. But with React, the process could look like this. Thought. User needs earnings for 2010 and 2022. My internal knowledge or provided database might have this. Let me check for 2022 first. Action. Look up company XYZ 2022 earnings in private DB. Observation. Result. Found 2022 earnings, $5 billion. Thought, okay, I got 2022, now need 2010. It wasn't in the private DB. I need to search external sources. Action. Search company XYZ 2010 total earnings public records. Observation. Result. Search found public financial report stating 2010 earnings were $3 billion. Thought. Excellent. I now have both figures. 2010 is $3 billion, 2022 is $5. I can formulate the final answer generation. The model then generates a response. Company XYZ's earnings were $3 billion in 2010 and $5 billion in 2022. This ability to reason, act externally, and observe allows it to piece together information from multiple sources or perform actions needed to complete the task, avoiding hallucination and making it much more capable.
Wow, that is a significant leap. It gives the AI a way to be much more resourceful and reliable when dealing with information gaps or dynamic data. We have really covered a lot of ground today in this deep dive into prompting techniques. It feels like we went from basic commands to some pretty sophisticated strategies.
We certainly did. Yeah, we started with the foundation, zero-shot prompting, just asking directly. Good for simple things, but limited. Then we saw how few-shot prompting, using examples right in the prompt, helps guide the model's format and style, really improving performance when you need specific outputs.
Then we tackled that complex reasoning piece with chain of thought, getting the AI to show its step-by-step work, which boosts accuracy and, importantly, gives us explainability. And we looked at assigning a role or persona to control the output's tone, style, and perspective, making it sound like who you need it to sound like.
Absolutely. And then the critical importance, especially for technical uses, of specifying the output format demanding JSON, Markdown, specific structures to get reliable, usable results for automation or other systems. And finally, we explored the advanced React technique, this loop of reasoning, acting externally, and observing, which lets the model fetch information or use tools dynamically to solve more complex problems.
It's really clear that understanding these different methods lets you move way beyond just simple AI interactions. You can truly start to sculpt the responses you need. Using the right technique for the right job seems to be the key to transforming AI from, a sometimes helpful chatbot into a genuinely powerful and reliable assistant.
Absolutely. Each technique has its strengths, its weaknesses, its best use cases, and often the most effective prompts actually combine elements from several of these methods. You might assign a role, provide a few-shot example for format, and ask for chain-of-thought reasoning all in one prompt. The whole journey of prompt engineering is often iterative, isn't it? You try a prompt, you see the result, you figure out what went wrong or what could be better, and you refine your approach using these techniques.
Thank you for tuning into this episode. As you can see, by using the right techniques, we can transform AI into a much more powerful assistant. Keep honing your prompting skills. We'll see you in the next lesson. Take care.
And maybe one final thought to leave you with as you continue experimenting. Consider this. How might AI models themselves be used to help you craft better prompts in the future? Could an AI analyze your goal, look at the information you have, and actually suggest the best prompting technique or help structure your prompt? It's an interesting possibility for your continued exploration. Food for thought.